Good morning, class. Here's Chapter 9, Sequences and Series, Section 9.2, Arithmetic Sequences and Series. So we covered 9.1, Sequences and Series, and here's Arithmetic Sequences and Series, and the objectives are: find the common difference for an arithmetic sequence, write terms of an arithmetic sequence, use a recursive formula for an arithmetic sequence, use an explicit formula for an arithmetic sequence. We looked at the concept of a sequence, and we said a sequence is a list of numbers written in a specific order. A sub 1, A sub 2, A sub all the way to A sub n, which is the first term, the second term, the nth or the general term of a sequence. A sub n is the general term, and n is the set of positive numbers, 1, 2, 3 to infinity, or natural numbers. Recursive sequence, also known as difference equation, is in the form of A sub n plus 1 is f of A sub n, which means the next term depends on knowing the previous one or previous ones. As an example, a Fibonacci sequence, we're given the first term f sub 1 is 1, the second one is 1, and then after that, in general, f sub n is f sub n minus 1 plus f sub n minus 2, meaning add the previous two. So 1 and 1 becomes 2, 2 and 1 becomes 3, so on and so forth. We also mentioned arithmetic and geometric sequence, and we said arithmetic sequence is a1 plus d, and all the way to the end. So recursively, a sub n plus 1 is a sub n plus d. Explicitly, a sub n is a sub 1 plus n minus 1d. And a geometric sequence is a sub 1 times r. So recursively, it's a sub n plus 1 is r times a sub n, and explicitly a sub n equals a sub 1 r to the power of n minus 1. That's what we mentioned. Also, the concept of a series and summation notation. S sub n, the sum of a sub 1 plus a sub 2 all the way to a sub n of the first n terms of a sequence. Then, so the sequence becomes a series when we add them up. This is sigma. This is the uppercase sigma. It's a Greek letter sigma and indicates a sum, addition. The sigma notation, summation of a sub I going from 1 to n, means add the terms a sub I, beginning with the first term and ending with the nth term. So the limits are the lower limit 1, the upper limit n. I is called the index of summation. A finite series, S sub n, we add up a sub 1 plus a sub 2 all the way to a sub n, and we write summation of a sub I going from 1 to n. However, in the case of an infinite series, normally we write s sub infinity instead of s sub n, a sub 1 plus a sub 2 all the way to a sub n, and it continues, and we write summation of a sub I as I goes from 1 to infinity. So the difference is the upper limit. This ends at some point, this continues indefinitely. Summation properties: if a sub 1, a sub 2, a sub 3, and a sub n, as well as b sub 1 all the way to b sub n, are two sequences, and c is a number, is a constant, then for every positive integers n, we looked at the following. The summation of c is nc, the summation of c a sub I is c times, the c comes out, it's a coefficient c, summation of a sub I. If you are adding or subtracting two, we can do them individually. Summation of I ends up being n times n plus 1 over 2. The summation of I squared is n times n plus 1 times 2n plus 1 over 6, and I cubed is n squared times n plus 1 quantity squared over 4. So those are the things that we have discussed. And now 9.2, arithmetic sequences and series. An arithmetic sequence, each term after the first one is found by adding a fixed number called the common difference to the previous term. This is an arithmetic sequence or arithmetic progression. We have a sub 1, then a sub 2 is a sub 1 plus d, a sub 3 is a sub 1 plus 2d all the way to the end, which is a sub n. The difference d between consecutive terms is constant, and the sequence can be defined by recursively. A sub n plus 1 is simply a sub n plus d. If you want any term, pick the previous one and add the constant difference, or distance is called, or explicitly by a sub n equals a sub 1 plus n minus 1 times d. Example 15913, as you can see, the difference is 4. Add 4 here. Same thing here, same thing here. So by the way, if you want to prove something is arithmetic sequence, you got to come up with the a sub 1 and d. As long as you can come up with those, that's an arithmetic sequence. The n term is given by a sub n equals a sub 1 plus n minus 1 times d. The sum of the first n terms is given by s sub n equals n over 2 times a sub 1 plus a sub n, if the first and the last term are known. Or if we don't have the last term, then instead of a sub n, we put this one. If you replace a sub n with this a sub 1 and this a sub 1 gives you 2 a sub 1, and the rest of it n minus 1 d. So you can do either or. So here's the synopsis of what we need to know about arithmetic sequences: a sub n plus 1, s sub n, and this is the explicit format, this is the recursive format, and s sub n. There are two ways to approach. Find the first 5 terms of arithmetic sequence when we know the first term, or a sub 1, is 7 and d is negative 3. So if you want a sub 2 is a sub 1, which is 7 plus the difference. So let's just quickly write down. This is the d. Okay. And they add up to 4. Now for the next one, everybody, we add the constant negative 3. That becomes a sub 3. They add up to 1. Again, we do the same thing. We add up negative 3. We get negative 2. And we want one more because 5 terms. So add negative 3 and we get negative 5. So let me just. So we wanted 5 terms. So it's clear what we are looking for, everybody. Negative 5. They add up to negative 5. Now, a sub 1 is given as negative 12. D is given as 5. And so we want a sub 2. Simply put, add a sub 1 and d. So a sub 1 is negative 12. D is 5. Add them up because they want 5 terms. So here's the first term. So their sum is negative 7. And now we continue. What is a sub 2? Add the difference of a 5, and that becomes negative 2. A sub 4, again, add the d, which is 5, and that results in positive 3. We need one more because we want 5 terms. We have a sub 1, a sub 2, a sub 3, a sub 4, and one more, add 5. You get 8. Show that the sequence is arithmetic. List the first term and the common difference. That's how you find out. Obviously, when we look at this one, we want to find a sub 1 and d. That's what they're asking. And clearly, the first term is 4. D is the difference between the two, which makes it -2 again. The way you do that, you can say a sub 2 minus a sub 1, 2 minus 4 equals -2. Now, it's important that you check with more than just a couple of terms. So if I add -2 to this one, do I get 0? Yes, so far it works. If I add -2, do I get this one? Yes. Because it works by checking, that's the proof. So the proof is you need to find a sub 1 and d and show that it works. The sequence is given as, and this is one notation, we use braces s sub n for n minus 1. So let's start with the first step. If I replace the n with 1, I get 4 minus 1, which is 3. So that should be the first step. Now, you can find the d in several ways. You can find a sub 2, a sub 3, and a sub 4. And we will look at it in a moment. Or if you want to find the d differently, s sub n minus s sub n minus 1, or you can say s sub n plus 1 minus s sub n. So what is s sub n is this one. What is s sub n minus 1? Replace the n with minus 1. So this is 4n minus 1 minus the brackets, braces, parentheses. S sub n minus 1 would be 4 times n minus 1 minus 1. So again, this is s sub n, and then this is s sub n minus 1. And we have 4n minus 4 minus 1, which makes it 4n minus 5. So what do we have here? Let me just write it up here. Four n minus 1 minus 4n plus 5, which makes it 4. Now, one other way that you can do that, replace the n. We've already done it with 1. We do it with 2, 3, 4, and we notice what happens. Let's observe that. So if I replace the n with 2, okay, I get 4 times 2, 8, minus 1 is 7. If I replace it with n equals 3, I get 12 minus 1, 11. If I replace it with n equals 4, 4 times 4, 16, minus 1, I get 15, and so on. Notice the first term is 3, then we go to 7, 11, 15, and so forth. We are adding the constant of 4. You really should check to be on the safe side. What about 2 minus 3n? Again, replace the n with 1. 2 minus 3 times 1, meaning 2 minus 3 equals -1. That is our first term. And again, you can go with the following terms, or if we go with this method, s sub n is itself minus, replace the n with n minus 1. So this is 2 minus 3n plus 3. So we have minus 3n plus 5. This negative we'll change it to plus 3n minus 5. These two cancel each other. These two add up to negative 3. So pretty straightforward. Now, if we want to do the same thing by replacing the n here with various numbers. For number 1, we came up with negative 1. So let's do 2. So we're going to replace the n with 2 and then 3 and 4 and see what happens. So if I changed it to 2, I get 2 minus 3 times 2. Let's say n is 2. I get 2 minus 6 minus 4. If I replace the n with 3, I get 3 times 3. 3 times 3 is 9. 2 minus 9 is minus 7. If I replace it with n equals 4, 4 times 3, 12, subtracted from 2, you get negative 10, and continues. And this is definitely one way to do the math. Notice the very first term, a sub 1 is negative 1. Then if you add negative 3, you get negative 4. If you add negative 3, you get negative 7, and so on. So that means you could find the difference in this manner. Find the second, third, and fourth term, and then just pick up 2 of them. For example, a sub 2 minus a sub 1 to find the difference between the two. Example 3, find the sum of the first 60 positive integers. First and foremost, that means 1 plus 2 all the way to 60. That's the meaning of it, okay? And we can use the summation, or we can use the fact that we have the formula for the summation of an arithmetic sequence. The reason it's an arithmetic sequence because we are just simply adding 1. So the sequence 1, 2, 3, 60 is the arithmetic sequence with the first term being 1 and the last term a sub 60 be 60. So we want S sub 60. Since we have the first and the last term, we're going to use this one, although you could use this one if we didn't have the. Whenever you have a sub 1 and a sub n, it's easier to use that one. So n over 2 or 60 over 2, a1 or 1 plus a sub n or 60. This is clearly 30, and times 61 gives you 1,830. Pretty straightforward. Find a sub 13 and a sub n for the arithmetic sequence given negative 3159. So first and foremost, clearly a sub 1 is negative 3. And then the common difference would be just 1 minus negative 3, or 5 minus 1, or 9 minus 5. And that gives you 4. But it is important to double check not just 1 minus negative 3, also check 5 minus 1, 9 minus 5. So we want to make sure that is a short thing. So we want a sub 13. So we want to use this formula explicit formula with n being 30. So we're using this formula with n being 30. Now we're going to replace the a sub 1 with -3, d with +4, and of course this becomes 12. 48 with -3 is 45. Please understand, you could count and get to the 13th term. However, if that n is huge, let's say they want a sub 258, I'm making something up. Definitely you have to know the formula, okay? You have to know the formula for this. In case you don't know the formula, you can easily figure it out. But when n is large, you can't. All right. Now, the next thing is that they're asking for a sub n, and a sub n, we can just write the general formula and keep it as n. In other words, the same formula, but this time we don't have a specific term. So a sub 1 is replaced by -3, d is replaced by 4. This is -3, this is 4, and this is -4. And so -3 and -4, they add up to -7. So a sub n is 4n minus 7. And you really have to check. So again, quickly, how do we check? Replace the n with 1. Do we get -3? Yes. Replace it with 2. Do we get +1? 3. Do we get +5? So you check your work. It doesn't take long after you find the general term. It's extremely important to do so, everybody. Find the formula for the general term a sub n of the sequence 5, 8, 11, 14, 17, and so on. Well, the first term is 5. 8 minus 5 is 3. So add 3, you get 11, 14, 17. It's an arithmetic sequence which has a sub 1 equals 5 and d equals 3 for sure. So if that is the arithmetic sequence with the given information, you just want a sub n, plug it in into a sub n equals a sub 1 plus n minus 1d. By the way, n minus 1 times d, d times n minus 1 makes no difference, okay? A sub 1 is 5, d is 3 times n minus 1. So we're going to distribute, this becomes 3n minus 3, and 5 and -3, they add up to 2, 3n plus 2. And you really should check. So after you find this, you say, okay, let's see. If n is 1, do I get 5? If n is 2, 3 times 2, 6 plus 2 is 8. If it's 3, 3 times 3, 9 plus 2 is 11, and so forth. At least check 3 of them to be on the safe side, at the very least. All right. The sum of the first 17 terms of an arithmetic sequence is given as 187. If A17, the 17th term is given as negative 13. We want to find A sub 1 and D. In other words, we want to make sure that we understand the arithmetic sequence. And an arithmetic sequence is known as long as we have these two pieces. The first term, A sub 1 and D. Sometimes they ask you to find S sub n or A sub n and things of that nature, but these are the two elements we should find. So the sum of the first 17 terms, that means this is S17. That's the meaning of it. And so if we go with the, since this is S, if we go with this formula or this formula, okay, so S sub n is n over 2 A sub n plus A sub n. So S sub 17 must be n over 2, 17 over 2, A sub 1 plus A 17. So S17, we use this formula, and we just plug in any 17 plug-in. And what is this equal to? 187. What is this equal to? Negative 13. So we have the left side as 187, and inside A sub 1 we don't have it, but A sub 17 we do. Instead of distributing and making it more difficult, get rid of this fraction. How do you get rid of this fraction? Multiply by its reciprocal, which is 2 over 17. One 187 is divisible by 17, is 11 times 2 is 22, and move this, and A sub 1 becomes 35. Let's find the D. And one easy way, we know A17 is minus 13, so we're going to use this formula. A sub n is equals A sub 1 plus n minus 1 times D, so we want A sub 17. It's A sub 1 plus 17 minus 1 times D. The reason we want that one, because this is known, so is A sub 1, so we can find the missing D. In essence, we are dealing with a system of equations. So this is negative 13. A sub 1 is 35. This is 16D. Subtract 35 from the left side, you get negative 48. Divide by 16, D becomes negative 3. So what we were given in essence was a system of equation where S17 was given as a specific number 187. A17 was given as a specific number negative 13. So this is the system that we solved. There were two equations, two unknowns. Suppose that an arithmetic sequence has A sub 8 and a sub 16. A sub 8 equals negative 16. A sub 16 equals negative 40. We want to find a sub 1d and then evaluate S12. In other words, remember, an arithmetic sequence is known if we have a sub 1 and d. So they are really giving us two equations, two unknowns. What is the first equation? A sub 8. Again, we're going to use this formula, everybody. So a sub 8 is a sub 1 plus n minus 1, 8 minus 1 times d. And a sub 16 is a sub 1 plus n minus 1, 16 minus 1 times d. Those are the two equations. And this is the system. We know a sub 8. So in other words, this equals negative 16. This equals negative 40. So we have two equations, two unknowns. Remember how we solve systems. Well, it's easy to get rid of a sub 1 if all you have to do, if you multiply one of these, doesn't matter which one, by negative 1. So if I keep this intact, if I multiply this one by negative 1, solve the system, multiply by negative 1, this becomes negative a1, this becomes negative 15d, this becomes positive 40. And now when I add them up, these two cancel each other. These two give us negative 8d. These two give us 24. And we get d. Now you can use one of the equations. For example, this one, a sub 1 plus 7d equals negative 16. Replace it with negative 3. So a sub 1 plus 7 times negative 3 equals negative 16. So we have negative 21. Move it, make it positive 21 with negative 16 is 5. So we have a sub 1, we have d, we want s sub 12, and we are going to use either this or that formula. Because we don't have a 12, we're going to use this formula, this one. Again, if we have a sub 1 and a sub n, it's easier to use this one. We don't have it. We're going to use this formula. And so because we want s sub 12, n is 12. So replace the n with 12. 2 times a1, replace it with 5, plus n minus 1 times d, and replace it with negative 3. So this is divided by 2 is 6. This is 10. This is 11 times negative 3 minus 33. So this is minus 23 times 6. We get negative 138. Find the summation of I going from 1 to 10 of 4i plus 8. And we can go back to sequences and series, the previous section, and use the formulas that we had. Or we may notice that this represents an arithmetic sequence. The first term, replace the I with 1. 4 times 1 plus 8 is 12. And the 10th term, because we are going to use this formula now, replace the I with 10, you get 48. And by the way, you can write a few terms to see that, just in case, class. If you go with I equals 1, you get 12. I equals 2, you get 16. I equals 12. 3, you get 20. And right away, you recognize this as an arithmetic sequence with a sub 1 being 12, with d being 16 minus 12, or 4, 20 minus 16. In essence, this 4 represents the d. So since it's an arithmetic sequence, we are going to use this one, and we get, again, this is one way to do that. N over 2, so we want S sub 10, everybody. We want S sub 10, everybody. So N is 10 in this formula. A sub 1, we found it to be 12, with A sub 10 being 48. This is 5. This is 60. Their product is 300. Find the formula for the nth term of the sequence graphed below. If you were to connect the lines, you get the points, you connect the line with a negative slope. Just for the sake of argument, the very first one, we can see it has coordinates 1, 3.5. The next one has coordinates 2, 3. And you can see that this has a negative slope, and y equals mx plus b has this equation. When you have two pairs, you know how to calculate the equation of a line. Let me remind you. The slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Three minus 3.5. 2 minus 1, we get negative 0.5 divided by 1. Y minus y1 equals m times x minus x of 1. So if I use the first point, y minus 3.5 is m negative 0.5 x minus 1, and you get this equation. So it is a linear equation. So the sequence, remember, the difference between the dots that you see and a solid line represents this equation, solid line. Okay, if we It's hard to see this dashed line. Let me actually use some sort of color. This line, okay. And now a sub n is a negative 0.5 a n plus 4. The difference between the two, this is a line, okay, no interruption in between, but this contains a bunch of points for n being 1, 2, 3. In this case, 1, 2, 3, 4, 5, 6. If there are more, then you write them. If it's indefinite from n goes from negative infinity to infinity, okay? Of course, I'm talking about integers. If it's all the way to infinity, 1 to infinity, positive integers. A mosaic tile floor is designed in the shape of a trapezoid. This is trapezoid. 30 feet wide at the base and 15 feet wide at the top. The tiles 12 inches by 12 inches. So each one is 12 by 12. 1 foot by 1 foot. Are to be placed so that each successive row contain one less tile than the row below. How many tiles will be required? So first and foremost, this is 15 feet and this is 30 feet. So 30, then we go down to 29. So we just take one off. And then 28, 27, 26, and so forth. That's the idea. So the top one has 15 tiles. The reason is because 12 inches is 1 foot. Okay, 15 feet. So this is 1 foot, 12 inches. Okay. So this is 12 by 12 or 1 by 1 feet. Okay, 1 by 1 foot. And so you have 15 tiles here, you have 30 tiles here. So if you go from the top, this one is 15, the next one is 16, 17, 18. If you go from the bottom, this one is 30, the next one goes down 29, so on and so forth. So you are dealing with an arithmetic sequence in essence. So the idea is that you want to find the sum starting from 15, the next one is 16, you want to go all the way to 30. That's the concept. Okay. And this 15, 16 to 30, this from 15 to 30 represents an arithmetic sequence with the first a sub 1, the first term is 15 with the difference of 1. So notice you want to add them up, you can use the concept of arithmetic sequence. The first term is 15, d, the difference is 1. And since we want to go from 15 to 30, please understand that means n is 30 minus 15 plus 1, 16. So n is 16. A sub n or a sub 16 is 30. And s is a question mark. S is what we are looking for. And if you have any doubts, you start counting 15 and 16 and 17. That means n is 16, okay? So S sub n is n over 2, a sub 1 plus a sub n. This is the easier one to use. And we know n is 16, a sub 1 is 15, and a sub n or 16, a sub 16 is 30. This is 8. This is 45. And their product is 360. How many tiles do we need for the entire floor in the form of a trapezoid, 360 tiles. That's it.